This video and its contents are the property of Kids in Space, and may not be copied or reproduced without the express written permission from Kids in Space. Welcome to Module 4, The Future of Drones, the Mars Ingenuity Project.
As a departure from previous modules and videos, today we're going to learn about the future of drones. This will take the form of the new Mars rover experiment featuring the Ingenuity drone. To explain further, over to Gary.
Hi all, my name is Gary Yule. I am Chairman of Salford Astronomical Society and Salford Observatory. I have been involved in astronomy and spaceflight now for over 20 years, and I am here to give you an insight into drone usage and planetary exploration. Drones are now being used in lots of different aspects, including exploration on other planets. I am sure you're all aware that NASA have launched the Mars 2020 mission and the launch of Perseverance and Ingenuity. As well as Perseverance rover, NASA have added a new bit of technology in the way of a completely experimental craft, Ingenuity, a drone helicopter. The first of its design to be able to fly and survive in the harsh Martian atmosphere. Ingenuity is an experimental flight test and is what's known as a technology demonstration, a project that seeks to test a new capability for the first time. Previous groundbreaking technology demonstrations include Mars Pathfinder rover, Sojourner, and the Mars Cube-1 CubeSat that flew by Mars. Ingenuity features 4 specially made carbon fibre blades arranged in 2 1.2 metre long counter-rotating rotors that spin at around 2,400 RPM. This is about 8 times faster than a standard helicopter on Earth. Ingenuity includes innovative batteries, avionics, sensors, telecommunications and other designs and algorithms. Many of its other components are commercial off-the-shelf parts from the world of smartphones. Including 2 cameras, an inertial measurement unit, an altimeter, an inclinometer for tilt angles and computer processors. The helicopter does not carry science instruments and is a separate experiment from the Mars 2020 Perseverance mission. Ingenuity will be the first aircraft to attempt a controlled flight on another planet, and with conditions on Mars this will prove quite a task. Mars has beyond bone-chilling temperatures, with nights as cold as minus 130 degrees Fahrenheit, minus 90 degrees Celsius at the Jezero crater, where the mission is due to land. These temperatures will push the original design limits of the off-the-shelf parts used in Ingenuity. Tests on Earth predicted temperatures indicated that they should work as designed, but this will still be determined on arrival at Mars in February 2021. One of Ingenuity's first objectives when it gets to the Red Planet is to just survive the frigid Martian night for the first time. Another challenge for Ingenuity is that Mars has a rarefied atmosphere, just 1% of the density of ours here on Earth. Because the Mars atmosphere is much less dense, Ingenuity is designed to be light, weighing in at just less than 4 pounds. The rotor blades are much larger and spin much faster than would be required for a helicopter of the same mass here on Earth. Mars does give a little help in the fact that the gravity of Mars is only 1/3, 38% equal to that of Earth's. That means slightly more mass can be lifted at a given spin rate. There are also other challenges of communication delays, inherent part of the communication with the spacecraft across interplanetary distances, which means the helicopter's flight controllers at Jet Propulsion Laboratories won't be able to control the helicopter with a joystick. Therefore, Ingenuity has to fly autonomously. The command to fly will be sent to Ingenuity well in advance, and the engineering data will be returned to Earth after the flight takes place. Ingenuity will communicate through the Mars Perseverance rover, which will then in turn communicate with Earth. In careful steps over 5 years, engineers on Ingenuity's team were able to demonstrate it was possible to build something that was lightweight enough and could generate enough lift in Mars' thin atmosphere to take off from the ground. Using a special space simulation chamber at Jet Propulsion Laboratories, they first showed that a helicopter could lift off in Mars' thin atmosphere in 2014, and then in 2016 that it could fly in a controlled way. They proved the helicopter could be built to survive in Mars' environment and operate as designed in January 2018 by flying the helicopter test module in the chamber with full functionality that would be required for Mars. In January 2019, the team completed test flights with the actual vehicle now in orbit on its way to Mars. Taking off from the surface of Mars and hovering will confirm the previous tests and give a practical insight into the operating of a helicopter on Mars. Given all the first Ingenuity is trying to accomplish, it has a long list of milestones that need to be passed before takeoff and landing in the spring of 2021. These include surviving launch from Cape Canaveral, now accomplished, the cruise to Mars and landing on the Red Planet, safely deploying to the surface from the belly of Perseverance rover, autonomously keeping warm through the Martian cold nights, and autonomously charging itself with a solar panel. Then if Ingenuity succeeds in its first flight, the helicopter team will attempt up to 4 other test flights of about 300 meters within 30 Earth days window. Ingenuity is designed to demonstrate technologies needed for flying in the Martian atmosphere. If successful, these technologies could enable advanced flying vehicles that are capable of reaching parts of the surface that rovers cannot reach, such as steep slopes and craters, and may be included in future human and robotic missions to Mars. Among the possible uses of future helicopter on Mars, offering a unique viewpoint not provided by current orbiters overhead or by rovers or landers on the ground, high-definition images and reconnaissance for the robots or humans, and access to terrain that is difficult to reach. A future helicopter could even carry light but vital payloads from one site to another. I hope this gives you an insight into Ingenuity and the future use of drones in space exploration and the possibilities of future careers in the designing and engineering of such technology.
As well as the exciting Mars project featuring Ingenuity, there are several other innovative ways that drones are likely to evolve in the future. These include deployment by utility companies, construction company research methods, used in the running of farms, and civil engineering company building and construction. Water utility companies employ drones to check the status of waterways, lakes and reservoirs, plus their retaining walls and dams. In fact, this was done in 2019 when the UK had the highest rainfall on record, causing one dam in Greater Manchester to suffer structural devastation. A drone was used to check for damages, as it was unsafe for people to do so in the conventional manner. A drone was used to get up close to survey the affected area of the dam, enabling the utility company to carry out the inspections and decide on the most appropriate corrective action, without putting people's lives at risk. Farms actively put drones through their paces whilst checking on the growth of crops. They can also be flown, to aid the management of farmland. This may include the movement of livestock, and identifying the state of field repairs such as fences and gates. Leading civil engineering and construction companies already make use of drones to monitor building construction and provide evidence of completed work, facilitating payment for each stage of work completed. This method of drone operation can also be used together with advanced virtual reality techniques to show existing or potential clients how their building will look internally and externally, during construction or prior to starting a project. As drone costs reduce, coupled with their increased capabilities, they will become commonplace for a variety of civil jobs conducted by small to medium-sized companies, plus town councils. If you have difficulty completing the quiz or research homework, please email the address shown on screen. Thank you for taking part in Module 4, we look forward to you joining us for Module 5 next week.